Is the power series a sum from n equals 1 to infinity of 0.1 to the n times x to the power of n convergent? If so, what is the radius of convergence? Before we answer the question, analyzing the power series, notice it's centered at x equals 0 because we have x to the power of n, where in the form below x sub 0 is equal to 0. Also notice how the power series resembles the geometric power series shown here on the right. To determine if a power series is convergent or divergent, as well as the interval of convergence and radius of convergence, we apply the ratio test or root test. Based upon the form of the power series, let's apply the root test, which means we need to determine the limit as n approaches infinity of the nth root of the absolute value of 0.1 to the power of n times x to the power of n. In this form, you can see why I chose the root test. When we take the nth root of something raised to the nth power, it simplifies perfectly. This simplifies to the limit as n approaches infinity of the absolute value of 0.1x. And since the absolute value of 0.1x is not affected by n, the limit is equal to the absolute value of 0.1x. And this limit must be less than 1 in order for the power series to converge. And therefore we set the absolute value of 0.1x less than 1 and solve the absolute value inequality. For the next step, let's multiply both sides by 10. Because the 10 is positive, we can bring it into the absolute value. This gives us the absolute value of x is less than 10, indicating x is less than 10 and x is greater than negative 10. And now we know the power series does converge on the open interval from negative 10 to positive 10, and therefore the radius of convergence is 10. But let's also determine the interval of convergence. To do this, we also need to test the endpoints of x equals negative 10 and positive 10. So if x is equal to negative 10, meaning we substitute negative 10 for x back into the original power series, we have the sum from n equals 1 to infinity of 0.1 to the power of n times the nth power of negative 10, which simplifies to the sum from n equals 1 to infinity of the nth power of negative 1, giving us negative 1 plus 1 minus 1 plus 1, and so on. We should be able to recognize, since the terms don't approach 0, by the nth term divergence test, the series diverges, and therefore the power series diverges at the endpoint of x equals negative 10. And now we test x equals 10, which gives us a sum from n equals 1 to infinity of the nth power of positive 1. And once again, this diverges by the nth term divergence test, and therefore the power series diverges at x equals 10. So now we know the interval of convergence is the open interval from negative 10 to positive 10, and therefore the radius of convergence, the distance from the center to either endpoint, is positive 10. I hope you found this helpful.